Okay, this is our first lesson in Surveying 1315, Surveying Calculations, otherwise known as math. We're going to start with a basic principle. Our subject of discussion is units of length, and people throughout history have used a lot of different units for measuring length, for measuring distance. In the United States, we use the U.S. survey foot, if you're a surveyor. International and scientific measurement is done in meters, and certain parts of the country, like Texas and Louisiana, use odd forms of measurement. In Texas, an official survey for the General Land Office uses a vara, which dates back to the Spanish colonization and the Mexican administration of Texas. And the arpent was during the brief period of French control of Louisiana. So anyway, like I say in the handout, the first principle, a unit of measurement should be appropriate to the thing being measured. You don't measure a house in millimeters. You measure it in feet if you're in the U.S., but you measure it in a way that is the simplest. And that's a very useful thing to remember. And the easiest way to do a thing is almost always the best way, the simplest way. Now, the definition of the U.S. survey foot is 39.37, well, the conversion factor is 39.37 over 12. That's the number of feet in a meter. How long is a meter? Well, it was thought for a long time that it was 1/10,000,000th the distance between the North Pole and the equator on a meridian running through Paris. That was what it was invented to do. And very shortly after it was invented and declared to be the official unit of measurement for France during Napoleon's reign, they redid the calculations and found out that that wasn't exactly correct, but no one wanted to go to Napoleon and say that that wasn't the case. So for a very long time, a meter was the length of two identical iron bars, or platinum bars, one in Paris and one in Washington, D.C. That worked very well until we got into the 1950s and the 60s, and we started measuring the speed of light. We wanted to know just how fast light was. Well, we found out, and then we had all these machines that did it, and they measured time and over a fixed distance, and therefore they knew the speed of light. Knowing the speed of light, you can then measure distances, and that's exactly what companies like Geodimeter and Hewlett-Packard did. They invented electronic distance measurement, so you didn't have to be stretching a chain or a tape over long distances. So anyway, what I'm getting at is that we now have a different definition of the meter, and you might actually get tested on that by the NCEES, but I probably won't, because it's just too much of a figure to memorize. It's about 297 million and change. That is the 1 meter is the distance light travels in 1/297,000,000th of a second. So it's a very, very small length of time, and only on account of the fact that we have machines that can measure that small a length of time can we accurately measure the meter. So anyway, you grew up with rulers, which were based on 1 foot, yardsticks, tape measures, and all that. So as engineers and surveyors, you will use a foot that's divided into 10 parts. Each part of that is 1/10 of a foot, because the decimal measurement of a foot is much easier to do. It's no more accurate than inches and fractions of an inch, but it's a lot easier. Remember my principle. The simplest way to do something, and the decimal feet works pretty well. So anyway, a yard is 3 feet. That's good. In most of the United States, if you are a surveyor, you will run into units of measurement called a pole or a rod, and that is 16.5 feet, and that's 1/4 of a chain, which is 66 feet. And I'll go into that in a later lecture on why 66 feet is so important. And a chain is 66 feet, and it's next on the list. That is 1/80th of a mile. So that's why the 66-foot distance is so useful. A furlong is 10 chains. Mile is 5,280 feet. Now, if you are a surveyor, you're going to work in stationing. And in the United States, stationing is nothing more than units of 100 feet. So if you have something that is 152 feet from the beginning point, that station is 1 plus 52. It's a very simple way of working, and it makes doing calculations for construction, and particularly road and pipeline construction, very, very easy. Go back to the principle of the simplest way to do things is usually the best, and when you start working with stationing, you realize just how useful it is. Anyway, the figure that I want you to remember is the conversion factor for meters and feet, and that is 39.37 over 12. So to convert from meters to feet, you multiply by 39.37 over 12. To convert from feet to meters, you divide by that number. Now, principle 2, a measurement is more accurate and defensible in court than a calculation or an estimate. Why do I bring this up? Because as surveyors, so often we write down a distance between 2 points when we have not actually measured that distance. We have measured in say a triangle. We're occupying one corner of the triangle, seeing the other corner, and measuring the angle and the distance between ourself and that point, and ourself and that point, and calculating the distance that we are not actually measuring. So we have 2 measurements of distance and 1 calculation. And a lot of times you will write that down as being a measurement. It's not a measurement, it's a calculation. Let's see. Oh, principle 4. Don't mix up units of measurement in one operation. It will drive you and everyone else crazy. So other units of measurement you need to know. The vara in Texas is 33 1/3 inches, and that's defined by the state legislature. A league is 5,000 varas squared. That is a piece of land which is square and 5,000 varas on a side. An arpent in Louisiana is approximately 192 feet. A nautical mile is 6,076 feet, approximately. We'll be covering why that particular unit of measurement is important. And a marine league is 3 nautical miles, and that's used in boundary disputes, as in how much land on the continental shelf the state of Texas owns. If you're going to survey in Texas, you really want to look at the next 4 lines. 1 vara equals 33 1/3 inch. 1 vara equals 2.777778 feet. 100 feet is 36 varas, and 1 mile is 1,900.8 varas. The important thing is that you know how to convert between units of measurement, because you have to do that all the time in Texas. You have to convert from varas to feet, feet to varas, and when you get into the public land survey system, you have to know how to convert from poles and chains, etc., to square feet for your calculation of acreage. But that's another lesson. So that's enough to introduce us to units of length, and then we'll get on with units of area, or measuring area.